So in this example, we're being asked to simplify the cubed root, and this is more of a challenging problem. So again, this is a cubed root, and what makes this challenging is that we have a negative underneath our cubed root. So remember, the index, in this case it's a cubed root, or 3, right, tells us how many of the same number or same variable we need in order to pull that number or variable out, okay? So what I'm going to do here is rewrite this negative 16 the following way. So I'm just going to rewrite the problem. We have negative 2, and then the cubed root of. Now think about how I can rewrite negative 16. I can rewrite it the following way, as negative 1 times 16, right? That is negative 16, so we're just breaking it apart. And then just rewriting what we have x cubed, and then y, and then z to the 5th. So now that we have that negative 16 broken apart, it may be a bit more visual. Think about how you can rewrite negative 1 so that it has an exponent of 3. Because remember, if we have an exponent of 3, that means we have 3 of the same number, right? Negative 1 times negative 1 times negative 1. So if I just put an exponent of 3 here, that's still going to be negative 1. Because again, right, negative 1 times negative 1 times negative 1 is equal to negative 1. But again, since my index is 3, I have an exponent of 3, that tells me that a negative 1 can be pulled out. Alright, so when I do that, I'm going to do negative 1 times a negative 2, and that's going to give me positive 2. So now I have this. I have positive 2, and then the cubed root of, again, we pulled out that negative 1. It's no longer there. We just have 16, and then x to the 3rd, y, and then z to the 5th. Okay? So let's work on 16. Let's work on simplifying that down. So I'm going to take the cubed root of 16. And just using prime factorization, we can get 4 and 4. And then we're going to get 2 and 2, and then 2 and 2. So again, I need 3 of the same number in order to pull that number out. So here I have 3 2's, meaning 1 2 can get pulled out, and this is going to stay behind. Okay, so I'm pulling a 2 out, so I need to do 2 times 2, which is 4. So now I have this. I have 4 cubed root of, again, this 2 stayed behind, so I have 2 x to the 3rd, then y, then z to the 5th. Okay? Next, we can move on to our variables. So this one's easy. I have x to the 3rd. Again, it matches my index, meaning an x can come out. So just rewrite this again. Let's erase this. I'm going to have 4. Again, an x can come out. Then I have the cubed root of, and then I'm going to have 2, y, and then z to the 5th. Okay, so if I move on to y, there's nothing I can do there. I don't have 3 y's in order to take one out, right? So there's nothing I can do there. But with z to the 5th, just writing it right here, right, I can rewrite this the following way. Z to the 3rd times z to the 2nd. That is z to the 5th. And look, that means a z can come out. This is going to stay behind. So my final answer is going to be this, and we'll do it in a different color. Alright, so just rewriting it, we're going to have 4 x, again the z can come out, and then we're going to have the cubed root of, and then we'll have 2 y, and then z squared. Again, that stays behind. This here is going to be our final answer. Okay, and that is it.